Hello, my name is Alexa, and for my Module 3 presentation, I'll be discussing logistic regression, and I'm going to specifically be discussing treating maternal periodontal disease, and we're going to be looking at how we can predict antibiotic use from APGAR score, birth weight, and the mother's BMI. So to start off, we can look at what our variables mean, and we coded antibiotic use, which is a yes or no question, as 0 and 1 in this model, and reduce the number of factors in the Z to simplify the model. And APGAR score at birth, which is a 0 to 10 score, has been labeled as a Z. Next, we can do a regular linear regression first, and we can see from here that BMI is the only significant variable, telling us that there is a significant relationship between BMI and antibiotic use. However, the coefficient is negative, so as BMI increases, antibiotic use decreases. We can now look at the diagnostics for this regression, and these are all concerning shapes. We can see that our binary variable is present, as indicated by the lines, and outliers are also present. Next, we can go into our logistic regression. And to start off, as Press and Wilson noted, an advantage of using logistic regression is that it is robust and is often used in biological and medical applications, as we're doing here. These authors also noted that, and this is a quote, explanatory variables are binary. We cannot expect to accurately predict the probability that the dependent variables will be in a given state. This is why it is important that our only binary variable is the dependent variable, which holds true in this data. So next, we conduct logistic regression because we are using data that does not fit the assumptions of the linear modeling. So logistic regression data is turned into a straight line or linear data that represents the log odds of that data that we're working with. As with the regular linear regression, BMI is significant with a negative coefficient. Regression coefficients represent the log of the odds. So since this output is based off log odds and is therefore centered around 0, we can say that if we have an APGAR score of 0, our log odds of having to take antibiotics decreases by about 1. So for individuals in the APGAR or Z1 group, there is an increase in this relationship. So since the residual deviance is smaller than null deviance, our predictors improve the model fit. Next, we can take a look at this histogram of antibiotic use. And now we can go into our odds a bit deeper. So to start off, odds tell us the probability of something happening and the probability of something not happening. And probability does not mean the same thing as odds. So the value of log odds is centered on 0 and is what we converted the data to make it linear. And when we have a negative number, it represents a negative relationship with the predictor for log odds. So since odds are centered around 1, numbers below 1 indicate a negative relationship with the outcome variable, which we can see is here. And we can also have our confidence intervals, and our mean is 0.8. Next, we can go into our first prediction. So this demonstrates the likelihood of taking antibiotics, and this makes predictions about antibiotic use based off the mother's BMI, baby's birth weight, and APGAR score. Our APGAR prediction is below 1, so that indicates a negative relationship with the predictor. Next, we can go into our second prediction, and APGAR and BMI together have values below 1, so this indicates that APGAR and BMI together have a negative relationship with the predictors. And this table was quite long, and so it's not fully pictured. And for our third prediction, once again, our predicted probabilities are below 1, indicating a negative relationship. We can now assess our model fit with the McFadden pseudo R squared, and our number here is 0.02 or 0.03 rounded. And this is low and demonstrates a poor fit. We can now do a model comparison. And so comparing each added variable, we can see that adding these predictors improves the model fit. However, there is not too much improvement between each predictor. And lastly, we can do diagnostics for our logistic regression. And these do, again, look concerning. We do see an outlier, and We do have our binary variable in here. And that is all I have